Good morning, my dear students. Welcome back to online class. So today we are discussing about a motion chapter, and today I want to complete detailedly about distance and displacement. See, so today I will discuss about distance and displacement with one good example, and with this example we will conclude some relations. So already I discussed about some relations, distance and displacement. The relations are distance is never be less than the displacement. Distance is maybe positive, negative, and distance is never be zero. Displacement is maybe zero. So all these relations we will conclude with one good example. See here, already I told the motion chapter means one case is it is along a straight line, another case is it is along a circular path. So now I am taking a straight line path. How distance and displacements are vary. See, the simplest type of motion is the motion along a straight line. So the simplest type of motion is motion along a straight line. So here we will describe this with one best example. See, just we have to consider an object is moving along a straight line path. It is a straight line path. Here we can observe many positions. One position is at O, another position is C, another position is B, another position is A. So for example, you see here, one object starts its journey. For example, you can see the object starts here from O. We call it is a some reference point. Already I told reference point. What is the meaning of reference point? What is the meaning of frame of reference? So see, the object start its journey from O, which is treated as a reference point. And after that, let it be A, B, and C represent the positions of the object at a different instance. Of course, these all are also reference points. What is the meaning of frame of reference or reference point? Means it describes the position of an object or location of the object. Now see here, it is an important condition we have to consider here. At first, the object moves through C. The object moves through C from O and B, and finally it reaches the A. So then it moves back along the same path and reaches C through B. So here condition is, it is a condition. Through this condition we will describe the different relations about distance and displacement. Here the object starts journey from O, we call it as a reference point. So here the object starts from here, after that it reaches to C, and after that it reaches to B, and again finally reaches to A. From that again it moves back along the same path through C from B. So then here you see the total path length covered by an object is, what is actually object start here, total path length covered by an object is, it is moved from O to C and C to B and B to A. Again it reaches A to B and B to C. The total path length is nothing but already told. Distance means what? Total path length covered by an object. Total path length is nothing but what? O to A. It means OC plus CB plus BA. Again AB plus BC. Why? Because already told the object starts from O, it reaches to C, again it reaches to B, again it reaches to A, again it's moved back along the same path A to B and B to C. Hence the total path length covered by an object is OA plus AC. Finally OC plus CB plus BA is nothing but OA. OA equal to what? Here OA equal to OC plus CB plus BA. See, here from here to here it is a 60 kilometer. It is in the form of kilometer. Why? Because for each two intervals 5 kilometers vary is there. See, 0 to 5, 5 to 10, 10 to 15, 15 to 20, like that. So OA equal to OC plus CB plus BA. So hence OA equal to 60, or OA is also equal to OC. It is nothing but 5, 10, 15, 20, 25. OC is nothing but 25. OC to CB, that is nothing but CB. 25 plus 10, 35. 35, again you can see 5, 10, 15, 20, 20, 25 plus 25. So finally totally it is a 60 kilometer. And again it reaches along the same path from A to B and B to C or AC. So here 5, 10, 15, 20, 25, 30, 35. So further we can see the total path length covered by the object is OA plus AC. Hence it is initially OA is nothing but 60 km, AC is nothing but 35 km. Finally 95 km. It is nothing but what? Total path length covered by an object. Total path length covered by an object is nothing but what? Distance. So for that only, that is the distance covered by the object. Here we are not taking any directions. So for that only, it is actually it is moving from O to A, and again it reaches A to C. We are not taking any direction. For example, it is along x-axis, it is along negative x-axis. For that one, it is a plus and it is a minus. But we are not assumption that positive and negative. Why? Because the distance is a scalar quantity. It have only magnitude. It is having only numerical value. Hence, distance having only magnitude and there is no direction. So distance is a scalar quantity. Now here my question is, now we are discussing distance is 95 km. Here my question is, displacement is also 95 km. Just you can see. So can the magnitude of the displacement is also equal to the distance traveled by an object? See now. Consider O to A distance is 60 km. Again O to A is displacement is also 60 km. Why? Because along one direction, along a straight line motion, distance is should be equal to displacement. Already we told last class, along a straight line motion, along a particular direction, distance must and should be equal to displacement. Hence here O to A is 60 km. Hence here O to A is 60 km for displacement also. But you can see here during its motion from O to A and back to B, the distance is covered is 60 km plus 25 km, 85 km. Why? Because see, during its motion from O to A and back to B, O to A and it is a O to A is nothing but 60 and back to B is nothing but how much? 5, 10, 15, 20, 25. Then 60 plus 25, 85 km. 60 plus 25 what? 85 km. But displacement is how much? Displacement here it is different. Why? Because you see along one axis is nothing but distance should be equal to displacement. But here displacement is a vector quantity. Displacement have magnitude and direction. You see this side is a positive x-axis, then it is a positive. Then you can see it is a negative x-axis, it is a negative. Already I told displacement is nothing but shortest distance between initial position and final position. You can see here the second question is it reaches O to A and again it reaches to A to B. Hence distance is 85 km. But what about displacement? Displacement how much? Displacement is nothing but shortest distance between initial and final position. Then it is the here initial position is 60 km, final position is 30. Then short 60 minus 35. 60 minus 35 how much? 25. But 60 minus 35 how much? 5, 10, 15, 20, 25. Then it is a distance is how much? Here distance from here to here it is a 35 km. It is a 35 km. Hence magnitude of displacement is not equal to the distance. Magnitude of displacement is not equal to the distance. But from the diagram, the object, you can see diagram, the object moves O to A and again it reaches O. From A, the distance covered is 120 km. Why? Because it is like diagram, it is like this. From here to here, O to A, it is nothing but finally it is a 60 km distance is there. So the object starts from A, it reaches to A is nothing but 60 km. Again the same object moves back to O, then distance is same, 60 plus 60, 120. But displacement is never be like that. Why? Because it is the shortest distance between initial position and final position. So whenever a particle is moving along a straight line motion or along a circular motion, again it reaches same position. For example, the particle starts from here, O, again at the end of its journey it reaches to O, means again here displacement is should be 0. Displacement should be 0. For that only, for one complete rotation, displacement must and should be equal to 0. Hence, from this we will conclude distance is maybe positive or negative, but it never be 0. Distance is maybe positive or maybe negative or maybe positive or maybe negative, but it never be 0. Why? Because for example, you can take along x-axis it may be positive, along y-axis it may be negative, but it never be 0. It is in the form of any numerical value. So then, but displacement is maybe 0, maybe positive and maybe negative. Hence here see relation, already I told this, distance is always greater than or equal to magnitude of the displacement. Now you see one important problem, that is, a particle is moving along a circle of radius r with a time period t. Calculate distance and displacement for one complete rotation, for half rotation, for 1/4 rotation. See, for distance, one complete rotation is nothing but, yesterday already given this one. One complete rotation is nothing but circumference of the circle. Circumference of circle from basic geometry 2 pi r. Why? Because it is moving along a circular of radius r with a time period t also. Time taken to complete one rotation is called time period. So for one complete rotation is nothing but distance, circumference of the circle. But for one complete rotation, for example, a particle starting here, again it reaches same position at end of its journey. So but it should be 0. Why? Because displacement is the shortest distance between initial and final position. For second question, you can see, for half rotation how much distance and displacement. For half rotation distance, you can see, so for half rotation distance, for full rotation means it is a 2 pi r, but distance for half rotation means from here to here. For half rotation means, full rotation means 2 pi r, for half rotation means 2 pi r by 2. It is nothing but pi r. 2 pi r by 2 is nothing but pi r. You can see, for full rotation means displacement is 0, but for half rotation from here to here it is the shortest distance between initial position and final position. From here to here it is r, from here to here also it is r, then r plus r equal to 2r. But you can see third case, 1/4 rotation. It is not a half rotation, it is a 1/4 rotation. 1/4 rotation. For full rotation 2 pi r, for half rotation 2 pi r by 2 pi r. For 1/4 is not, rotation is nothing but 2 pi r by 4. Then 2 pi r by 4 is nothing but pi r by 2. Then for displacement, you can see, for one complete rotation it is moving along a circle of radius r, again it reaches same position. For a half rotation means it is moving from here to here, it reaches to here. For 1/4 rotation is nothing but it is moving from here to here. But we know from here to here center of the circle radius should be constant. From here to here the radius should be constant. But we don't know this. We want to calculate this only. Why? Because for 1/4 rotation is nothing but this only. Then from, it is like right angle triangle. From this diagram it is a hypotenuse square equal to side square plus adjacent side square. Then x square equal to r square plus r square. X square equal to 2r square, x equal to root 2 These are the important relations between distance and displacement. Already once again I will conclude these relations. Is for in straight line motion in particular direction or along x-axis or along negative x-axis, it means any one particular direction or in straight line motion, distance should be equal to displacement. But in circular motion, distance is always greater than the displacement. And another relation, for one complete rotation, displacement should be 0, but distance is 2 pi r. Hence, distance is always greater than or equal to displacement. So, displacement is always less than the distance, or displacement is equal to distance. Thank you.